Our final type of equation, a new type in this section, is rational equations. And that is anything of the form involving rationals. So if our variable might make an appearance in the denominator, we would say this is a rational equation. And the way that we solve these is relatively familiar. Looking at the notes, we want to clear the fractions by multiplying by the LCD. So in my experience, the trickiest part once we complicate these equations by allowing for the variable to be in the denominator is determining what the LCD actually is. So I like to look at every term and look at all of the factors of every denominator. So I have a 5, I have an x here, I have a 1 in this term, and here I have a 2 and an x. Well, I already have x taken care of. X is in the LCD already, so I don't need another one. So my LCD is going to be the product 5 times x times 2 times 1 if you want, which is 10x. So I'm going to multiply both sides of this equation by that LCD. So 2 over 5x plus 3 and 1 over 2x. So each one of those is going to get multiplied by 10x. On the left, we're going to have to distribute, since we have a sum. So 10x times 2 over 5x plus 10x times 3. And on the right, we just have 10x times 1 over 2x. Now at this point we definitely want to simplify. If we did this right, we shouldn't have any fractions. So I'm noticing x and x will cancel in this first term, as will the 10 and the 5, leaving me with a 2. So we have 2 times 2, 4 from that first term, 30x from the second term, and similarly the 10 and the 2 will cancel, leaving me with 5, and the x will cancel. So I think this equation, which is arguably identical, is a lot easier to solve. And we can do so by subtracting 4 over to the other side. So 30x equals 1. And if we divide by 30, we see that x equals 1 over 30. Now this type of equation is another that you absolutely have to check your solutions. These rational expressions have some danger zones, right? We want to make sure that we don't come up with a solution that isn't actually allowed to even be plugged into the original equation. So let's plug that back in. And again, we're plugging that back into the original equation, so 2 over, and we want to leave ourselves lots of room, 5 times 1 over 30, plus 3. So that's my left-hand side. And my right-hand side, which I won't say is equal yet, is 1 over 2 times 1/30. Okay, well my left-hand side, I notice the 5 and the 30 can cancel, leaving us with 2 over 1/6 plus 3. And 2 over 1/6 is the same as 2 times 6 over 1 plus 3. So this is 12 plus 3, which is 15. And on the right-hand side, we see this is equal to 1 over, we cancel the 2 and the 30, 1/15, which is equal to 1 times 15 over 1, which is equal to 15. So we have a valid solution in x equals 1/30. Let's see one more of that type of problem. Okay, here we see another rational equation, and we would like to clear the fractions. This is just a mess of an equation as is. So let's determine what the LCD is. So I'm looking through, and in my first term I see I have a 3 in the denominator. Here in the second term, 49 and x are both factors. So really, what is 49? That's 7 times 7. Let me write that in its factored form. That's 7 squared. In our next term, we have 49 also, so I don't need anything else. I already have 49 taken care of. And in my last term, I see we have 21. So 21 is 3 times 7. We already have a 3 and we already have a 7. So those are going to cancel, and so is the x, which means we don't need anything new in our LCD for that last term. So we're going to have 3 times 7 squared times x, and I usually like to leave my LCD factored like this. That makes it more easy to keep track of what's going to cancel. So if I multiply the left-hand side by the LCD, we get 3 times 7 squared times x times 1/3 minus 3 times 7 squared times x times 8 over 49x. And on the right, we'll have 3 times 7 squared times x times the first term, 16 over 49, minus 3 times 7 squared times x times 1 over 21x. Now this looks excessive. This looks like a lot of stuff to keep track of, but if you cut corners in this stage, if you start to see stuff that's going to cancel, you may lose track of things. So at least starting out, I would recommend showing all of the pieces as you're going, particularly with this type of problem. It can be very easy to lose little things that'll totally throw off the problem later on. Okay, so in our first term, we can cancel the 3's, and we're left with 7 squared times x. In our second term, we can cancel 7 squared and 49, and we can cancel the x's. So we're left with the 3 and the 8 only. On the other side, our 7 squared and our 49 will cancel, and we're left with 3 times x times 16. And finally, we'll cancel the 3 with the 21 and one of the 7's with the remaining 7 from the 21. We'll also cancel the x. So we're left with one of the 7's, and that seems to be it. Okay, so our equation already got quite a bit better. Here we have 49x minus 24, and on the right we have 48x minus 7. So this is a very manageable equation. If I isolate my x's on one side, I'll subtract 48x and add 24 to both sides. We get x on the left equals negative 7 plus 24. That would leave us with 17. And we're done. That was our solution. X equals 17. And we'll go back and check that in the original equation. This would be a good one to use your calculator for. So if I take out my calculator, I'll plug things into the left-hand side. 1/3 minus 8 over 49 times 17. Okay, that's going to be something weird. Let's type that in. I get something along the lines of 0.3237295. We'll round it to 1, 2, 3, 4, 5, 7 decimal places. On the right-hand side, if we plug 16 over 49 minus 1 over 21 times our x value of 17. We get really funky numbers. Let's see if they work out. So 16 over 49 minus 1 over the product, 21 times 17. You'll want parentheses around that in your calculator. So what do we come up with? We get 0.3237295, basically, if we round in the same way. So the left-hand side and the right-hand side are equal when we plug in 17, which means x equals 17 is our solution. So that's the approach. You want to identify every term on every side of the equation, and then determine all of the factors that appear anywhere in those terms. So that is it for 4.4, those 3 different types of new equations that can eventually and usually be solved using quadratic techniques. Go ahead and get started on those homework problems and bring any questions that you have to class.